Hello, everyone. We're the Cook Biotech sprayable design team. This is our BME Design Forward 2 outreach activity. The team members are Jesse Fan, Xavier Fan, Yenbo Feng, Tishan Zhu, and our advisors, Dr. John Puccinelli. Today we're going to be talking about what is biomedical engineering, some of the tracks within biomedical engineering, as well as talk about demonstrating an activity that relates to the biomechanics side of biomedical engineering. Here's a team introduction. On the right, you can see a picture of the members of the team.
Hey everyone, I'm Yenbo Feng, and my track in the biomedical engineering is the bioinstrumentation, and my future interest is in the robotic application in the biomedical field.
Hi, I'm Xavier Fan, and my track is bio instrumentation, and my interest is in prosthetics designing, and my future plan is to become a biomedical engineer.
Hi, I'm Tishan. My track is bioinstrumentation, and my interest is in brain implants. I aim to be a neuroengineer in the future.
Hi, everyone. My name is Jesse. I'm on the biomaterials track, and my interests are how different biomaterials interact with different human factors in vivo condition. And I'm interested in pursuing a career in the medical device industry. So what is biomedical engineering? BME is a multidisciplinary STEM field that combines the application of different sciences as well as the engineering principles to the development of technology and different materials that can be used in different medical procedures for medicine and healthcare. It's a very broad and evolving field and has many different focus areas. Some of the focus areas that we're going to be talking about today are bioinstrumentation, biomechanics, biomaterials, and tissue engineering, as well as biomedical imaging. Like I said before, there are many other focus areas as well within the BME field. So what can you do with the BME degree? Well, there are many different career options that one can do with a BME degree, such as work in the medical device industry. And some of those positions include research and development engineers, quality engineers, as well as manufacturing engineers. In addition, you can pursue higher education degrees after your undergraduate degree. So some of those options are master's degree or join a PhD program. And in the future, you can work in academia as well as research. And lastly, one of the many options are you can pursue a healthcare career. So some of those options are furthering your education in medical school, dental school, as well as veterinarian schools are other options. And next, Tishan's going to talk about the different focus areas within the BME field.
Thanks, Jesse. So first track I'll talk about is bioinstrumentation. The bioinstrumentation utilizes many electronics and also measurement principles to develop electronic medical devices that can be used for diagnosis and treatment for diseases. Some examples are cardiac pacemakers and also some brain implants that could cure Parkinson's, for example, and also blood pressure monitor and kidney dialysis. Next track I'll talk about is biomechanics. Biomechanics investigate the motion of biological process from systematic to molecular level to further understand medical treatment options. Some examples in this field are prosthetic device and microfluidics, which investigates the motion of fluidic molecules that is in a very micro level. And next track I'll talk about is biomaterial and tissue engineering. In this area utilizes synthetic or natural materials to interact with tissues for medical, therapeutic, or diagnostic purposes. And some examples in this field are bone graft, for example, some like replacement for the teeth, and also artificial blood vessels, which are usually used in some cardiac diseases and drug delivery vehicles. With some special biomaterial, the drugs could be like targeted to certain area and also could be delivered safely. And Yanbo will talk about bioimaging track and also our team design project.
So the biomedical imaging field, it's dealing with signals basically, and this field focuses on the enhancement of non-invasive human imaging for detection of pathophysiological pathway through the measurements of the body's response to physical phenomena. This is kind of hard to understand, but one example is the MRI. In the MRI, there's like a very large magnet that make all the hydrogen protons in the tissue rotate in the same direction, and then they use another magnet to and then they use another magnet field on a patient, and then the hydrogen proton at different tissue will rotate at different angle. So this can give out imaging for the doctors to evaluate. And other example of the biomedical imaging is the CT scan, the ultrasound processing, and X-ray. The CT scan is usually used for some organs, like a GI tract, and the X-ray is usually used for the bones. For example, if the bones are broken, it's usually be evaluated by X-ray. And one interesting fact about imaging is before any imaging technique appeared, doctor used to use a surgery called diagnostic surgery, which is a surgery that they use to check the issues in the patient's body. And the imaging technique really helps the invasive detection, so that surgery is really used now. And then I will introduce our team's project. As a bachelor in the UW Medicine, each medical engineering student need to work on a senior design capstone project. Our project is about development of novel liquid delivery system suitable for efficient and direct delivery of hemostatic agents to the lesion spot in the human body, for example, in the stomach. And our device will be hopefully used in the laparoscopic and open system surgery procedure. And some potential impact about our design is our design kind of allows for the application of liquid form hemostatic agent. For now, currently the most commonly used hemostatic agent is in the form of powder, and our device can provide a platform for liquid form agents. And our catheter tube on the design can allow for further access to the internal autonomy. And next, we will have Xavier to introduce some detail about our activity.
Hi, so our activity is about standing on eggs, and the first question we want to ask is what would happen if you stand on one single egg? And for this activity, what you need to prepare is a carton of eggs, a paper bag that is cut open and used to place under those eggs for easy cleanup after the activity, and also one single egg for demonstration of what would happen if you stand on just one egg. And as any normal person would imagine, standing on one single egg might gonna crack the eggs, the egg. However, if you stand on multiple eggs, it might gonna stand the weight of a human. And here's a demonstration of this activity.
Hi, I'm Xavier Fan. Since I have the weight of a mountain, our first test subject is my cat, who apparently is not into science, and that's why we're teaching her at home. The second test subject is a cat lady. Though adding only 4 letters to the name, the eggs now are bearing roughly 100 more pounds, and they are holding up just fine. I'm sure these eggs will make great breakfast tomorrow morning. Finally, I want to give my special thanks to my cat and my cat lady. They are both great animals, creatures. Thank you so much for watching and not suing us for abusing baby chickens.
And here's the explanation of that demonstration. So what I'm going to talk about is the relationship between force and pressure. And here's the equation, which is that the pressure equals the force divided by the area the force is applied to. And when you stand on multiple eggs, the area of pressure distributed would increase so that the pressure experienced by every single egg would be diminished. And then the eggs may not gonna crack. And here's the illustration of it, which is one foot on one single egg is going to crack, while if the foot is on multiple eggs, the weight is going to be distributed, the pressure is going to be distributed upon many eggs, and they may not going to crack. So please show us how you did it if you want, and you can click the link below and show a picture of you doing that just for fun. And thank you so much for watching.